What if I told you that understanding AWS security from an attacker's perspective could make you a better defender? Today we're diving deep into AWS red team fundamentals and the attack vectors that every cloud security professional needs to know. So, welcome back to the channel. I'm Lord Morak, and in today's video, we're going to break down the essential concepts of AWS Red Team using the comprehensive, this diagram I've created. Whether you're a penetration tester, security analyst, or just curious about cloud security, this video will give you the knowledge you need to understand how attackers think and mm, can operate in AWS environments. Let's start with the foundation. The AWS shared responsibility model. This is crucial because it defines the security boundaries between AWS and you as the customer. Basically, uh, the AWS manages the physical infrastructure, the data centers, the servers, and the networking hardware. The hypervisor network controls the virtualization layer that runs your instances. The service availability, it's ensuring their servers are up and everything is correct. And basically, the customer manages the data encryption, the classification, protecting your sensitive information, the identity and access management, controlling who can access what is in your environment, also the operating system, the network, and the firewall configuration, securing your applications instances. This division is critical because attackers often exploit misconfiguration on the customer side. Not all AWS infrastructure vulnerabilities. Now let's look at the primary targets that red teams focus on AWS engagements. The three main servers the attackers typically target are the identify access management. This part it means that the user accounts, the roles and policies basically are gold mines for attackers, and also the access keys and the temporary tokens can provide persistent access. And also misconfiguration permission often leads to privilege escalation. The Elastic Compute Cloud, basically the instance metadata service is a common attack vector. The security groups and keepers can be misconfigured. Also, running instances often contain valuable data or serve as pivot points. Finally, the simple storage service. It's basically the bucket policies. The ACLS are frequently misconfigured. Public access configurations can expose sensitivity data. S3 buckets are often the end goal for data filtrations. These services are targeted because they're fundamentals to most AWS deployments are and often contain the most valuable assets. And then on this section with the common attack vectors, you need to understand how attackers operate is key to defending against them. Let's explore some of them. Well, basically, red teams typically follow these patterns, the credential harvesting, looking for exposed access keys in code repositories, configuration files, or environment variables, and also abusing instance profiles that have excessive permissions, targeting developers' local AWS credentials. Also, the privilege escalation phase, basically exploiting overall permissive AMI policies, performing role assumptions attacks to gain higher privilege, leveraging service link roles and cross account trust. Finally, the data exfiltration, enumerating S3 buckets to find sensitive data, stealing the EBS snapshots and MIs that might contain credential or sensitive information, and usually accessing databases and other data stores. Basically, these pictures are often work in combination, and attackers might start with credential harvesting, escalate privilege, and then exfiltrate the data. Then we got the reconnaissance and enumeration. Before launching the attacks, red teams need to understand the target environment. This is where reconnaissance comes in. The reconnaissance phase involves gathering information about the target AWS environment. Uh, some of the essential AWS commands are AWS ticket color identity, AWS AM list users, AWS S3LS. Basically, the first one identifies the current user or role, the second one enumerates AMI users, and the third one lists accessible S3 buckets. Some of the tools you can use, for example, Scout Suite and Prowler, it automates security assessment tools. You can also try a Pacu framework that is specifically designed for AWS penetration testing. You can try also Cloud Mapper that helps visualize AWS environments, and you can also take a look at the manual API calls that for custom enumeration scripts. Basically, this phase is critical because it helps attackers understand the attack surface and identify potential vulnerabilities before launching more aggressive attacks. Then we got the persistence mechanism. Once the attackers gain initial access, they want to maintain it. Let's take a look how they establish persistence in AWS. Persistence in AWS can be achieved through several methods. It can be through backdoors, creating hidden users or roles that blend in with legitimate accounts, attaching policies to existing entities without detection, and you can establish cross-account trust relationship for future access. And for the infrastructure persistence, you can use Lambda functions, serverless backdoors that are hard to detect, cloud formation stacks that the infrastructure as code that can recreate the access. You can also go for system manager documents that can execute commands on multiple instances. Finally, we got the event bridge rules that can trigger malicious actions based on AWS events. These some of the persistent mechanisms are particularly dangerous because they can survive incident response efforts and provide long-term access to the environment. Then we got the defense evasion. Sophisticated attackers don't just break in, they try to stay hidden. Some of the defense evasions in AWS include log manipulation, disabling CloudTrail to prevent logging of API calls, deleting specific logs to cover tracks, using VPC endpoints to avoid internet-based logging. Also, for a bit more advanced technique to defend detection avoidance, you can use regional hopping, moving between AWS regions to confuse defenders, time-based attacks operating during off hours or holidays, low and slow techniques, spreading activities over time to avoid triggering alerts, legitimate service abuse, using AWS services in ways that appear normal but serve as malicious purposes. Um, Basically, these techniques make it extremely difficult for security teams to detect and respond to attack in real time. Then we got the essential red team's tools. You can Some of the professional red teams rely on several key tools like Paku, CloudGo, the Rhino Security Labs tools. That basically security labs tools. It's including S3 scanners and other specialized utilities. You can use Weird AAL, that AWS attack library with numerous of models. You can use some of these reconnaissance tools that basically the AWS CLI and SDKs. It's the foundation for any testing. You can also use Nmap with AWS scripts for network discovery. You can use Shodan and Sensis for finding exposed AWS resources. And you can also try to look for certificate transparency logs, that it's for discovering subdomain and services. These tools automate many of the manual process involved in AWS penetration testing and make attacks more efficient and quite effective. Now let's get sick with the defender's perspective. AWS provides several native security services for detection. Uh, the core security services could be CloudTrail API call logging, that basically logs all API calls and provides an audit trail. You can use GuardDuty, that is for uses machine learning to detect threats. Security Hub centralized security findings from multiple sources. Config, it's monitor compliance and configuration change. Some of the key indicator of compromise, it could be unusual AP calls, especially from new locations or at all times, cross-region activity, unexpected resource creating in different regions. Failure authentication attempts, especially repeated failures, resources enumerations, patterns that suggest reconnaissance activities, and the key is correlating these indicators and understanding normal versus abnormal behavior in your environment. Now let's connect all these techniques to the MITRE attack frameworks for our cloud environments. This will give us a structured way to understand the complete attack lifecycle. Well, basically, MITRE attack is a global access of knowledge base on that categorize attacks. It's the why behind an attack and the techniques, the how attackers achieve their goals for cloud environments. This framework is invaluable for mapping real-world attack scenario. Let me walk you through each tactic with specifically AWS examples. Well, first we start with the initial access phase. This is where attackers gain their initial entry point into your AWS environment. They will use valid account, think expose MI access keys in GitHub, hardcode the credentials in application, or compromise an employee account with AWS console access. They could use exploit public facing application, vulnerable web application running on EC2 instances, misconfigured API gateways, or unpatched services in ECS containers. The executing phase. Once inside, attackers need to execute their payloads, command scripting using AWS System Manager run command to execute the scripts across multiple EC2 instances. Then we got the serverless execution, invoking Lambda functions with malicious payload or creating new Lambda functions that execute on schedule. Then we got the persistence phase. The attackers want to ensure that they can return it even if their initial access method is discovered. They can use it with account manipulation, creating a new user with unusual names, adding access keys to existing services accounts, or modifying existing user permission. They can usually use create account, establishing new AWS accounts within an organization, or creating cross-account trust relationships that provides backdoor access. Then we got the privilege escalation phase, moving from limited access to administered privilege. Uh, they can use valid accounts to exploiting overprivileged services roles, abusing AMI partial permission to assume high privilege roles. They can use elevation control, exploiting wildcard permission in AMI policies, or leveraging resource-based policies with overlay broad access. On the defensive version, avoiding detection by security tools and teams. Uh, to the Imperial Defenses section, they will use disable cloud trail logging, modifying guard duty settings, or deleting security relating the Lambda functions. On the modified cloud compute, altering security group rules, modifying VPC flow logs, or using VPC endpoints to avoid internet-based monitoring. On discovering, mapping out the AWS environment to identify valuable targets, the cloud service discovery, enumerating C3 buckets, listing EC2 instances across regions, discovering RDS database and their configurations. Also, you can use account discovery using AWS ST get current identity to understand the current permissions, the some of the click commands that I was telling you, listing the AMI users and roles, discovering organizational structure. So understanding this framework helps you in several ways. The texturing engineer, the purple team exercise, the gap analysis, and the incident response phase. Each phase it will help you to understand it, to see the real world attacks, and try to map it. Today we walk through the AWS Red Team fundamentals and some of the attack vectors. First, we share the responsibility model. We examine the common attack vectors like credential harvesting and privilege escalation. We discuss the persistence mechanism for maintaining access, the defense evasion tactics to avoid detection. Finally, we map everything with the MITRE attack framework to understand the complete attack lifecycle. This will give you a comprehensive view of the AWS cloud security from both offensive and defensive perspective. Basically, just you need to remind these key points like the shared responsibility model, define security boundaries, the AMI, the EC2 and S3 are primary attack targets, and attackers use sophisticated evasion techniques. Detection requires understanding normal versus abnormal behavior. The MITRE tag frameworks provide structure for understanding threats. And if you found this video helpful, please like, subscribe for more cloud security content. In the comments, let me know what specific AWS security topics you'd like me to cover on the next one. And if you're serious about learning cloud security, check out the resources. I'm going to leave some of the links with this information. And thanks for watching.
If you're passionate about malware and cybersecurity, I've got something awesome for you. Check out our academy focused on ethical malware projects. We offer a range of courses to boost your skills. First up, there's Introduction to Windows Malware Development for those getting started. Next, dive deep with Building a Custom RAT to create your own remote access tools. And for those wanting to analyze and understand malware, there's Introduction to Malware Analysis. But that's not all. We also have our Malware Development modules, mini courses that cover specific topics like evasion techniques. Join us and level up your skills